Okay, let's see how we did. How about Megan? What does sine of 2 equals 0.909 mean? Which is the angle measure? 909 is the angle measure. And then, so what is the 2? The radians. Hassan, what do you think about that? You agree with that? Okay. Daniel, what do you think?
Yeah.
So 0.909 is the angle measure and 2 is the radians. This was the response. Agree with that or not? It's the opposite. 0.909 is the radians and 2 is the angle measure. Not quite. We're mixing. We're got our lines crossed. So this is kind of something that we should know based on all our hard work here. Flora, what do you think? What's going on here? Yeah.
The horizontal diameter.
0.909 is the vertical distance above the horizontal diameter.
When
Marlene is dying to jump in. Yeah, please.
So what I got from it is that the 0.909 is like the vertical distance above the diameter, and
Okay.
then the 2, like the input of the sine would be like the radians.
Okay. So the input into sine 2 is radians, and this is the vertical distance above the horizontal diameter. Now I see some nods. Yeah, Alexandra.
Yeah, it's 2 is like where the point is swept above 3 o'clock.
And what does the 2 mean? So, yep. 2 what? 2 radians of openness, which is equivalent to 2 radius lengths of arc length, right? Which is about there. So this is saying 2 radians of openness of the angle, in other words, is the rays that cut off an arc length of 2 radius lengths. And so then the 0.909 is? Marquise. Okay. Vertical distance above the midline of the horizontal diameter. And so why does looking at this point, why does 0.909 make sense? Okay, it's fraction of the radius, but so why specifically 0.909, Angelica? Why is it, 0.25 is a fraction of the radius too. So why 0.909? Adam?
Because that's how many radius lengths it is above the horizontal diameter.
Right. And why, looking at the picture, why does that make sense?
Because it's not all the way at the top, which would be 1.
But almost. Almost, 9/10 of the way up, almost all the way up at this point that we get from sweeping 2 radians. Okay? Input, angle measure, swept counterclockwise from the 3 o'clock position. Output, fraction of a radius length above the horizontal diameter. Fraction of a radius length above the horizontal diameter. Okay, so now if you were to put the inverse sine of 0.909, what would you get? You should get 2, right? Yeah, right? Because if sine of 2 is 0.909, then the inverse of 0.909 should be 2. Do it. So you do like second sine to get the inverse sine. What'd you get? Who said 1.14? Your calculator's broken. You got to make sure you're in radians. You shouldn't get an error. Did anybody get 2? What'd you get? 1 point? Okay, what's going on here? So here's what we want to talk about today is what is the sine inverse function? What is the sine inverse function? Because it's doing something strange. And so when you're plugging numbers in your calculator and using the sine inverse button, you have to know what you're getting. Okay? 1.14 is correct. It's correct. It should not be 2. But so now, if you have to understand what you're getting when you then put in sine inverse of 0.909, why it's not 2 and why it's something else. So that's what we're going to develop today. Okay? All right, so we want here is our unit circle and our sine curve. All right, so we got a unit circle and then we got our standard sine curve. So what is the input and output of sine theta? So we're focusing on sine theta. What's the input and the output? One more time. What's the input and output? What goes in and what comes out when you use the function sine theta? Let's see. Adam, what do you think? Angle measure? Which angle measure? Right, swept counterclockwise in the 3 o'clock position. Okay, and then what is the output? Justin. What's the output? What's the output quantity? Okay, fraction of what distance? But you said a fraction of the distance. The fraction is a fraction of what? Fraction of the radius length above. Okay, so if we had the inverse function, what would that process be? So talk to the person next to you. What would the input, if we had the inverse process of sine, that we'll denote this way with our inverse notation, what would the input be and what would the output be? Go. Tell the person next to you. Okay, input would be what? What would the input be? Denise.
The input would be the fraction of the radius length.
Okay. Yep. And the output?
Would be the.
That's right. So they switch, right? They switch. So now we'd have the vertical distance above the horizontal diameter in radius lengths or in fraction of a radius. And the output would be the angle. So when we're working with sine inverse, this is crucial. You have to know what do you put into it and what does it give you. You got to know the meanings of those. So it's the reverse. They switch from what sine is. Okay. So then if that's the case, then let's look at these right here. So we're saying that f inverse of x is this reverse process of sine. And I want you to find f inverse of 1, f inverse of 0, f inverse of -1/2, and f inverse of pi. Okay? And so you'll be utilizing the unit circle that you memorized. Okay? So using your unit circle knowledge. And again, you have to have in the forefront the input and output of this reverse process. You have to be constantly going back to that all the time so that you're making sense of the numbers. Okay? So try these 4. The reverse process of sine. what would those values be? I'm going to start hanging back some home.
Yeah.
Wait, no calculators. Put your calculators away. You're using the unit circle. Sorry, that's what I said. You need the unit circle. No calculators. No calculators. You're thinking about what the input means and what the output means, and you're remembering from your unit circle. So you're going to get all messed up if you use your calculator, okay? This is. Has to be. Aisha? Darwish? Darwish here today? Bill? Zero. Right. Darwish is not here, right? Okay. So what's our input again? Our input is what? Vertical distance. So think about it this way. Vertical distance of, so think of that red line now showing the input. So we want a y value, or vertical distance of 1, right? So the input is 1, which puts us where on the circle? At the top. So now the output is what quantity? The angle measure that would get us there, right? What angle measure is that? Pi over 2. 90, yeah, could be 90 degrees. Pi over 2. Okay? All right. Input. So F inverse 0. Input 0 means vertical distance. Output, angle measure swept counterclockwise from 3 o'clock. So 0. What? It could be pi. Could pi work? Yeah, there's an angle measure. The angle measure pi gives us that vertical distance of 0 too. Anything else? We're done now, right? That's it? What about negative pi? Is that a real angle? Clockwise angles, negative, sure. We talked about that, right? Over here. See, if you can go negative, and that just means you're going clockwise around the circle. All right, negative 2 pi. Okay, now we're done, right? What about if we go around twice? Okay, you get the point. So we'll never be done, right? We never be done. There's an infinite number of angles that result in being 0 above or below the vertical diameter. Okay, negative 1/2. Who remembers their unit circle? Okay, So what angle gets us a y-coordinate of, or fraction of a radius length of a half below? 7 pi, not over 4, over 6. 7 pi over 6. Is that it? 11 pi over 6. Okay, again, but that's only in the first 0 to 2 pi. If I keep going around, I can keep hitting that spot that takes me 1/2 radius length below as many times as I want by just continuing to increase the angle measure. So there's more. Okay, what about this reverse process of pi? So what does that mean? That means we want to be 3.14 radius lengths above the horizontal diameter. What about that? So as I want to look for what angle will get me to 3.14 radius lengths above the horizontal diameter. What do you think? Bill, what do you think of that? You're not too sure. So where am I trying to get to? 3.14 radius lengths. Well, there's 1. There's 2. So 3 is up there in the, about at that beam up there, or that pipe, whatever that is. So what angle will get me up there? What's the biggest number of radius lengths I can get above the horizontal diameter? 1. Can I get an angle that'll get me 3.14 radius lengths above? No. Does not exist. It's impossible. So the first thing that we're seeing is that your output of this reverse process has to be between what? The input. The input of this reverse process has to be a number between what and what? -1 and 1. Okay? It has to be between -1 and 1 because there's no angle that will get us greater than 1 or less than -1 as a point, the distance of the point on the circle above the horizontal diameter. Okay, but then we're also seeing something else here. Is this reverse process a function? Is it a function, right? What was our definition of a function from a couple months ago? Function means that when you put an input in, what happens? You always get the same one single output, like a functioning phone. You put in the number, you always want to get the same recipient every time. That's a functioning phone. But if sometimes you get the pizza place, and sometimes you get your mom, and sometimes you get your ex, but the same number, it's not a functioning phone. All right, that's the idea of a function. So this reverse process, is it a function? No, because we can put in a vertical height and get lots of different angles out for that same vertical height. So if we want to call this the sine inverse function, we have to make an adjustment, right? Just without the way it is here, we can get many angles for the same vertical distance that we pick.
The first one's a function, right?
The first one, what's the first one?
The inverse of 1.
No, the function is f inverse. This is just plugging 1 into that function.
Well, because you were saying those ones don't work as functions.
No, we're only talking about one function here, and we're plugging in different values into that one function.
Okay, so inverse is not a function.
The way, yeah, not yet, right? So we have to make an adjustment. But yeah, so the reverse process without any conditions on it doesn't work as a function because for any y value that you pick in the circle, you're going to get, there's lots of angles that you'll get as a result. Okay? So what do? What we do is, in order for the reverse process to be a function, we're going to need a range of angle measures. So we need some range of angle measures that's going to cover every distance from -1 to 1 just once. Okay, so our input is our y-coordinate. So think about that input as that y-coordinate. So we need a range of angles that's going to just hit one angle for each y-coordinate from -1 to 1 that we pick. And we have to hit them all, right? So we have to hit, for every input value from -1 to 1, we need to just get one angle out. So we come over here to our graph, and now we're thinking opposite, right? Because we're thinking the input is the y value, and the output is now the horizontal. So I need a range of angles that covers every y from -1 to 1 just once. So let's try 0, let's try range angle. Let's try 0 to 2 pi. Okay, so if I do 0 to 2 pi, I'd be looking at this part of the graph right here. I'd be looking at, say, from 0 to 2 pi. This right here. Does it work? So if I only looked at 0 to 2 pi there, for any y that I choose, for any vertical height that I choose, do I get just one resulting angle measure in that range? For that, if I picked 0 to 2 pi as my range for theta? No. Here's a perfect example, right? Right here I'm picking this y value, something like 0.3. And what happened? I got this angle measure here, which would be this one. And I got this angle measure here, which is coming all the way around to the second quadrant, this one here. So this range of 0 to 2 pi doesn't work. I need a range of angles that's only going to give me one angle per value from -1 to 1. Another suggestion from instead of 0 to 2 pi? So I need just one angle for every y value I could put in from -1 up to 1. I just want to get one angle back. So I'm going to restrict this range to do it. What will work? Be fun. -pi to pi. So that would be from here to here. 0 to pi. So what did you say again? -pi to pi would be from there to there. Does it work?
No. It's half, just half. Negative half of pi.
-half of pi to pi. Let's try that. So you're saying from here, -pi halves to pi halves. So that would give me this part of the curve right here. So negative angles coming this way, starting at, say, -pi/2, sweeping to 0 up to +pi/2. Does that range of angles give me exactly one angle for every value -1 to 1? Does it work? It does. Okay? So that's what we do to make this thing a function. In order to make it a function, we have to restrict that output range to -pi/2 to pi/2. So here, watch it, ready? So we're just going to look at the right half of the circle and look at the range from -pi/2 to pi/2. And we'll just pick whatever angle we get in between those, in between -pi/2 and pi/2 to be our output for that corresponding input of a y-coordinate. So we have to be good with negative angles, right? So if I pick a negative y-coordinate down here, the way I'm showing it, the result of sine inverse will be a negative angle, right? A clockwise swept angle. Do you see that? So if I choose this as my input, this is like -0.4. So if I'm 0.4 radius lengths below the horizontal diameter and I want the corresponding sine inverse, it's going to be this, which will be a negative angle. Something like half of a radian, half of a radius length, but it'll be negative. Okay, so the inverse function for sine is called the arcsine or the inverse sine, and you see it two ways. You see it like this, arcsine, and you see it like this, inverse sine. So just to review, if you understand what's going on, I want you to write out what's the domain of this function, all possible inputs, and what's the range of this function, all possible outputs. So see if you've been tracking, listening. Can you write out what the domain and the range of the arcsine function is? What are all possible inputs? What are all possible outputs? Okay. Let's see here. Inputs. Matt, what are all possible input values? Okay, -1 to 1. Including those or not? Yeah. So it's like that. Why? Because the input is vertical distance now. Vertical distance, the least it could be is -1, the greatest it could be is +1. What is our range? What are all possible values of the range? What do we think? Brighton, did you get it?
So I think it's 0 to 2 pi.
0 to 2 pi. So if we pick angles from 0 to 2 pi, that'll give us one angle for every y input y value.
So negative pi over 2.
There you go. Good recovery. Okay, so the range is going to be all values from -pi over 2 to pi over 2. Look at the picture here. So here I'm showing you the input is the y coordinate. That's that horizontal line. And then you're going to have a corresponding output down here. When your inputs are negative, it's going to be a negative angle, a clockwise angle, output theta. When your y values are positive, you're going to have a counterclockwise angle between 0 and pi over 2. So this range from -pi over 2 to pi over 2 gives us one angle per y coordinate from -1 to 1. Please.
Is that why the range couldn't be like a pi over 2 to 3 pi over 2 or something like that?
It could be that, but that's not the most convenient. So yes, that would work. That would also give us one angle per. But then, so here's one way to think about that. If our input y coordinate was 0, what does it make sense that we want the angle to be? Kind of what would be the most logical choice if we had a 0? So if we had a 0 vertical distance, then we want that angle to be 0, right? Instead of pi, right? So 0 is a more logical choice. So the range that includes 0 would be this -pi over 2 to pi over 2. So it would work. What you're saying would work perfectly fine. It's just not the most convenient and logical. Okay, so here's some practice. No calculator, okay? No calculator. This is to see if you really get it. So we'll do A together. Arcsine of sine of 3 pi over 4. Okay? So where do we start? Do we start with arcsine or do we start with sine? We're going to start with sine. What is the sine of 3 pi over 4? Who remembers from your unit circle? What is the sine of 3 pi over 4? James. All right, so where's 3 pi over 4? Second quadrant? Right there. Remember what that?
Oh, it's 1/2.
Not 1/2. Square root of 2 over 2. Okay, now look. Now we're going to put the square root of 2. So we're talking about that angle right there. We started with 3 pi over 4, which is this angle right here. We put that into sine, and we get radical 2 over 2 right there. That's the output of sine. 0.707 radius lengths above the horizontal diameter. And now we're going to put that y value, that vertical distance, into arcsine. What's going to happen? It's going to give us an angle between what? Is it going to give us 3 pi over 4? No, because that's not in the range of arcsine. It's going to give us the angle between -pi over 2 and pi over 2 that gives an output of radical 2 over 2, which is right there. So what angle between -pi over 2 and pi over 2 gives a vertical distance of radical 2 over 2? Pi over 4. So if you put arcsine of radical 2 over 2 in your calculator, you will get the value, an approximation of pi over 4, not 3 pi over 4. So these problems really check to see if you know what's going on. You can't just, if you write 3 pi over 4, it's wrong. If you just say, oh, arcsine of sine, it must be 3 pi over 4. No, that's not right. It's going to give you pi over 4. Okay, so you can practice on these while I hand back some more homework. Okay? Don't use your calculator. Don't use your calculator. Practice the unit circle, practice the input and output means. You gotta have input and output means. No Chris today?
So sine is going to be negative. That's a coordinate.
I know.
Did both homework, rubber band, make it all the way around? There's some left over. Okay. How do they get pi over 4? So it's all about the input and output of what's going on here. So we're inputting the angle 3 pi over 4. The output is the vertical distance above the horizontal diameter, sine. Just that part right there. Square root of 2 over 2, which takes us to here. Now arcsine, its output has to be between negative pi over 2 and pi over 2. The output of arcsine has to be in this range so that we just get one angle per y value. So when you put that radical 2 over 2 in there, you're going to get what angle between negative pi over 2 and pi over 2 gives you that y coordinate. Pi over 4. It's what? Not two answers. There's only one answer, pi over 4. Because then arcsine would not be a function. We restrict the domain. We restrict the angles from negative pi over 2 to pi over 2 that can come out of arcsine. So if we were getting 3 pi over 4 and pi over 4, that would not be a function. So in our restricted range, the y value only pi over 4. Okay. Katie here. Katie. Araceli. Gomez. Okay. B. What's sine of 5 pi over 3? What is sine of 5 pi over 3? Come back. Oh. Sine of 5 pi over 3 is? Some of these examples. How about what quadrant is it in? Fourth quadrant. And the sign is? Negative square root of 3 over 2, right? It's right about there. So we're talking about this angle right here. Five pi over 3. Takes us into the fourth quadrant. Gives us a sine value of negative radical 3 over 2. Now we're going to take that negative radical 3 over 2 and we're going to put it into arcsine, which gives us the single angle between negative pi over 2 and pi over 2 that has that y coordinate. What angle between negative pi over 2 and pi over 2 gives the y coordinate of negative radical 3 over 2? No, it's got to be an angle between negative pi over 2, meaning swept clockwise from 0, to pi over 2, swept counterclockwise up to the top. Negative, it's got to be a negative angle. It's got to be this negative angle, which is negative pi over 3. The range is from negative pi over 2 to pi over 2. So if you're down here, if your y value is negative, it's going to be some angle between negative pi over 2 and 0 for the arcsine. So B, the answer to B is negative pi over 3. That's why we're doing these, to get an understanding of. So let's do another one. How about arcsine of this one, D, 7 pi over 6? First of all, what is the sine of 7 pi over 6? Just a negative 1/2. Is that right? Yep, it's negative 1/2. So it's this angle. So starting here, 7 pi over 6 is this angle right here. Has a sine of negative 1/2 right there. Listen, what angle between negative pi over 2 to pi over 2 gives a y coordinate of negative 1/2? Negative pi over 6. Is it starting to make sense? So the answer to D is there's only one answer. There's only one answer. It's negative pi over 6. Check it with your calculator. Check it with your calculator. Put in sine of 7 pi over 6. Get that. Take the arcsine of that. This is about, negative pi over 6 is about negative 0.51 or something? You should get an approximation at about negative 0.51 or 52. 52? Okay, so let's do the very first one we did. Sine of 2 is what? So no calculator, right? So sine of 2, we showed that at the beginning. Sine of 2 was 0.909. Right up here. Right there. Here is 2 radians, right there, 2. Okay, so we get 0.909 right there. We get the sine of 2. So what's the arcsine of the sine of 2 going to be? It's going to be this. So you see that this angle measure right here is equal to the one we want. So what is that? It's pi minus 2. Pi minus 2. And that's where that 1.14 was it? 1.14 came from. Because it's going to be this, the angle arcsine is going to give that one is the same as this one here, which is pi minus 2. Okay, we'll have